Science often will start with, simple enough, an observation. Ah, the moon. I observed the moon. From that observation, you come up with questions. I wonder what the moon is made of. Well, from those questions, you can come up with guesses as to the answer. An educated guess is what we call a hypothesis. Now, what's a scientific hypothesis? A scientific hypothesis is an educated guess that is testable. Got that? Let's see. The moon must be made out of Swiss cheese. That's my scientific hypothesis. It's testable, right? It's a guess, too, because it kind of looks like Swiss cheese with all the holes in it, okay? From a hypothesis, you can make predictions. Well, if I go to the moon, I should be able to have a picnic and eat some of that Swiss cheese. Okay? Now, what you need to do are some tests to test your hypotheses and your predictions. Well, let's go to the moon and find out. Do some experiments up there. Here's an experiment. You take a bite. Oh, it's a rock. Hey, it's not just a rock. Let's look at its chemical composition. Okay, we're doing tests. You know, we did go to the moon early on. 1969 was the first landing. And in the 1970s, we had lunar landings. And we did experiments on the rocks. And we found that the rocks had a composition that was very similar to the composition of rocks here on Earth. Wow. We did these tests, and from these tests, you know what? We made more observations. That's right. We made more observations. Wow, look, the rocks have the same composition, about the same composition as the rocks do here on Earth. Gee, I wonder why. More questions. Questions come from your observations. Hey, let's make a hypothesis. Let's say that the moon and the Earth have the same compositions because really they used to be one large body. And that one large body got split in half by some big asteroid or something like that. That's my hypothesis. If it's testable, it's a scientific hypothesis. From that, you should make predictions. Oh gosh, such an event might happen again in the future. From that, you make tests. And from those tests, you get more observations, then questions, and then scientific hypotheses, predictions, tests. It's a cyclical process. It goes round and round and round and round. What do we get from this process? What comes spinning off? Knowledge. Science is a way of understanding the universe. And as we go through this process, we gain knowledge. Not necessarily wisdom, but a focus on knowledge. When you do your experiments, you come up with evidence. What's important is that your evidence be reproducible. I'll simplify this for you. I'm going to do an experiment. Down here, I have a scale. I'm going to step on this scale because I want to measure my mass. I see my mass is 60 kilograms. Should be reproducible, right? Let's do it again. 60 kilograms. 60 kilograms. Pretty darn close. And after you see that your evidence is reproducible, you feel pretty good about it. Right? That's important. What if the scale was broken? The springs weren't quite right, and you really aren't 60 kilograms, you see? It's important to be able to have your experiments done not just in your own laboratory, but in other laboratories too. That's reproducibility with a capital R, you understand. It should be reproducible wherever you are in the universe, right? So, that is why it is that scientists will do their experiments in their laboratory, and then they will share their information, their data, how this experiment was set up, whatnot, with the rest of the world. So that another scientist in another part of the world or another part of the universe can try to reproduce the results. And if they can, then you really feel good about the knowledge that has come out from the scientific process. So reproducibility is a very important thing. And you know, if you're going to have your experiments done by other people, it compels honesty. It's like playing cards, and all the cards are laid out face up. because you want to show what you are doing, right? The scientific process compels an honesty. And if anybody's been found dishonest, you don't get a second chance among your peers. Hey, and as you collect all this information, you can put all this information together and come up with what we call a theory. A theory is a single comprehensive idea that has stood up to repeated scrutiny. In chemistry, we talk about the theory of the atom. We say that all matter is made out of these tiny little particles called atoms, right? That's a hypothesis, right? But it's been up for repeated scrutiny and reproduced, the results reproduced wherever. And pretty soon, you get this big consensus that everybody's thinking pretty well that matter is made out of these tiny particles called atoms. And we call that a theory. We can call it atomic theory. But just because we've all accepted it doesn't mean that it's not subject to change. If there is an experiment done somewhere that says, ooh, not all matter is made out of atoms, then the theory will need to be changed, or let's say modified. Now, does that mean the theory is weak because it's been modified? Or does that mean the theory is now stronger? That the more it is modified, the stronger the theory becomes. The theory of the atom is now much stronger than it was, say, 100 or 200 years ago when it was first introduced. Okay, now understand when you go through all these processes, it develops within the person what's called a scientific attitude, the honesty, all those attitudes that are important to have in doing science are summarized by this quote right here. This scientific attitude is one of inquiry, experimentation, honesty, and a faith that all natural phenomenon can be explained. That's the scientific attitude. And this has brought to us a lot of success in terms of understanding how the universe works and our place within that universe. Perhaps I should share with you now the story of the discovery of Teflon, because it's not just understanding that we get out of the scientific process. We get a lot of technology that comes from it also. Whereas science is the understanding of the universe, technology is taking that understanding and finding useful applications. And the two work closely together. Now, it was in the 1930s, a chemist by the name of Plunkett. He had filled up this cylinder, a gas cylinder with a gas, and one evening, and the next morning he came in and he opened it up and there was nothing there. The gas didn't come out. And it was sealed the whole night. He went, "Where did the gas go? I filled this cylinder up with this gas. Now it is gone." He could have just thrown the cylinder away, thought maybe the cylinder was junk. Or he had a scientific attitude of inquiry. He went, "Gee, where'd it go? I want to know. Where did it go? I filled this tank up the other night." And so he pulled out his hacksaw, cut the cylinder in half, looked inside, eureka, made a discovery. Let's look at it. Here's the cylinder that Plunkett cut in half. The night before, it was filled with a gas. The next morning, he found after cutting it in half, it was filled with a solid. There was a transformation of matter from one material to another. Here it is. This new material he discovered here is known as Teflon. Classic example where the scientific method has given rise to a technology that we use now, today, in our daily lives. Hey, as you learn about science, recognize science in itself is a useful thing to learn. But we want to learn science not for science in itself. We learn science so that we can learn more about our environment. Learning science is much like maybe climbing a mountain. You know, it might take some struggle going along the way, but the higher you go, the better the view. Science is a window through which we can perceive nature with greater clarity.